Have a good day, everyone. Welcome to Computer System Servicing Module. This is intended for Grade 12, entitled Understanding Domain Name System or DNS. This is under Learning Outcome 2, entitled Configure Network Services. This module is for Quarter 2, Week 3, Day 2. Learning Objectives. At the end of the learning period, the students should be able to A. Know the history of Domain Name System or DNS. B. Define Domain Name System. And C. Understand how Domain Name System works. Before we proceed to our lesson, let's answer the pretest. Directions. Read each statement below carefully. Write T if the statement is correct and F if wrong. Number 1. Computers are and were only able to communicate using numbers. The answer is true. Number 2. DHCP was developed as a sort of phone book that translates domain you enter in your browser into a computer-readable IP. The answer is false. Number 3. In the early 1980s, Paul Mokapetris came up with a system that automatically mapped IP addresses to domain name and the DNS was born. The answer is true. Number 4. Computers and other devices can communicate with each other via the internet or other networks, and each device is assigned shared IP address. The answer is false. Number 5. By web browsers interact through Internet Protocol IP addresses. The answer is true. Now, let us have a recap of our previous lesson relevant to our topic. Directions. Fill in the blanks, the missing words. This is the steps on how to install DHCP. Number 1. Adding a new role. Click blank from the initial configuration task window or from Server Manager roles. The answer is Server Manager. Number 2. Selecting the DHCP server role. When the Add Roles wizard comes up, you can click Next on that screen. Next, select that you want to add the blank and click Next. The answer is DHCP. Number 3. Network connection binding. Configure some basic IP settings and configure the first DHCP scope. It was shown the network connection binding and asked to verify blank. The answer is network. Number 4 to 6. Entering domain and DNS information. The wizard is asking, what interface do you want to provide DHCP services on? Took the default and click Next. Next entered blank, blank, and blank, and click Next. The answer is parent directory, add, and DHCP v6. Question 7 to 10. Adding a new DHCP scope. Click Add to add a new scope. Name scope. Configure the blank and blank IP address and blank default gateway. Type of subnet, wired, and activated the scope. Choose to disable blank stateless mode for this server and click Next. Then, confirm DHCP installation selection and click Install. The answer is ipconfig/release, ipconfig/renew, Windows 2008, and IP address. Let's proceed to our lesson. What is domain name system? A brief history of the DNS. 30 years ago, when the internet was still in its infancy, when you wanted to visit a website, you had to know the IP address of that site. That's because computers are and were only able to communicate using numbers. This is an IP address, 127.33.54.200. It's too long, hard to remember, and we, humans, are not robots. We needed a way to translate computer-readable information into human-readable. And it had to be fast, lightweight, and scalable. In the early 1980s, Paul Mokapetris came up with a system that automatically mapped IP addresses to domain names, and the DNS was born. This same system still serves as the backbone of the modern internet today. The domain name system is the phone book of the internet. Humans access information online through domain names. It converts human-readable domains names like www.google.com into Internet Protocol address like 173.194.39.78. Computers can only communicate using series of numbers. So, DNS was developed as a sort of phone book that translates the domain you enter into your browser into a computer-readable IP. Web browsers interact through Internet Protocol addresses. DNS translate domain names to IP addresses so browsers can load Internet resources. How does a DNS server work? Domain names such as example.com are easy to remember for humans, but less suitable for communication between computers in a network. To make sure that computers and other devices can communicate with each other via the internet or other networks, each device is assigned its own unique IP address. Similar to long phone numbers, IP addresses are difficult to remember for human users. The domain name system combines the requirements of humans and computers by enabling a connection, for example, to a website without having to know the corresponding IP address. DNS servers play an important role here. DNS servers translate domain names such as example.com into IP addresses. During this resolution process, the DNS records on the server are searched, and if available, the domain name data set is returned. If the IP address cannot be found on this DNS server, the query is sent to other DNS servers until the data for the respective domain is retrieved. When you enter a URL into your browser, it starts searching for the corresponding IP address in a local file stored on your PC. If it finds no information there, the request will be redirected until the IP address will be identified. Thereby, it passes the local DNS server, usually your internet router, the ISP's DNS server, and the root name server, which is accountable for the respective top-level domain. If there is still no information found, the request will be sent to the Network Information Center responsible for the zone. The information provided by authoritative name servers is binding and trustworthy for other servers. In contrast to that, your router or the ISP servers are non-authoritative. In order to answer repeated queries for the same domain more quickly, the information is temporarily stored in the DNS server's cache for a set of period of time. This period is called time to live, abbreviated by TTL. Depending on the server configuration, the TTL can vary between a few minutes and several days. How does a DNS query work? The best way to understand how each DNS server type works is to follow the DNS query trail. Step 1. The web client. You open a web browser and type http://www.google.com. The query leaves your browser and is received by the DNS client built into operating system. The best way to understand how each DNS server type works is to follow the DNS query trail. So, step 2, DNS local cache. The built-in DNS client checks its local cache to see if it has the associated numeric address already on file. If it does, it provides the address to the web client. If not, it sends a query to an external DNS resolver server residing on the internet. It's typically maintained by your internet service provider. Step 3. The DNS Resolver. This server resides between you and all other DNS servers required to get Google's numeric address. This server essentially takes control of the DNS query, temporarily become the DNS client. Step 4. The root name server. There are 13 of these servers maintained by the Internet Corporation for assigned names and numbers. Overall, this network keeps track of all the servers that maintain a directory of each domain, like .com, .net, .org, and so on. In our example, this network responds to the query by directing the DNS resolver to the address of a server handling the .com domains. Step 5. The top-level domain name server. TLD name server maintains a directory of a specific domain. They are managed by Inter-Assigned Numbers Authority, which is part of Internet Corporation for assigned names and numbers. When the .com TLD name server receives the DNS resolver's request, it responds with the address of an authoritative name server that keeps Google's actual numeric address. Step 6. The authoritative name server. This is the final step for the DNS query. This name server receives the DNS resolver's query and pulls up the DNSA record to retrieve Google's numerical address. However, if a domain or a subdomain has an alias like google.com, the DNS resolver will receive that information first, prompting it to send another request for the numerical address listed in the DNSA record. Step 7. The DNS resolver. With Google's numerical location in hand, the DNS resolver delivers the information to your PC's DNS client. The resolver is done for now until it receives another DNS query. Step 8. The DNS client. Now, knowing the numerical address, the DNS client hands the address over to the web client. It will also store the numeric address in its cache for later use. Step 9. The web client. Using the numeric address, the web browser sends an HTTP request to the server located at that internet address, which in turn responds with the web page you see in your browser. DNS servers are the foundation of the Internet's domain name system. They store public IP addresses and other data associated with host names. How does DNS work? The process of DNS resolution involves converting a host name, such as www.example.com, into a computer-friendly IP address, such as 192.168.1.1. An IP address is given to each device on the Internet, and that address is necessary to find the appropriate Internet device. Like street address is used to find a particular home, when a user wants to load a web page, a translation must occur between what a user types into their browser, example.com, and the machine-friendly address necessary to locate the example.com web page. DNS servers catch DNS records for faster lookups. Content delivery network servers catch content to reduce latency, and web browsers catch HTML files, JavaScript, and images in order to load website more quickly. DNS support both iterative and recursive queries. Under iterative, the client has to piece together all the information on its own. In recursive, the server would trying to gather information from other server if they don't have the answer. Let's proceed to activities. Directions. Label the roots of domain name system queries. Mix of iterative and recursive. The answer is number 1, computer will send recursive query to local DNS server. Number 2, local DNS server. Number 3, root server. Number 4, TLD server. And number 5 is respond to recursive query. To summarize the lesson, let's proceed to wrap up. Domain name system background. The domain name system is one of the foundations of the Internet. It is used in networking to make our life much easier. It helps people to do their jobs, check their email, or using their smartphones to explore in the Internet. Domain name system is a directory of names that match with numbers. The numbers in this case are IP addresses, which computers use to communicate with each other. Most descriptions of DNS use the analogy of a phone book. DNS is like your smartphone's contact list, which matches people's name with their phone numbers and email addresses. Then, multiply that contact list by everyone else on the earth. You integrate the values you have learned by answering the question. In valuing, the question is, we have learned the importance of domain name system in accessing information to computer network and to make our life easier in browsing Internet. Discuss how DNS work. You may answer this on your digitized worksheet. To make sure how far have you gone through to our lesson, let's answer the post test. Directions. Choose the letter of the correct answer. Number 1. Translate domain names to IP addresses to download Internet resources. A. DNS. B. Web browser. C. DHCP. D. URL. The answer is A. DNS. Number 2. It interacts through Internet Protocol IP address. Letter A. Web browser. Letter B. URL. Letter C. Server. Letter D. Web page. The answer is B. URL. Number 3. It's typically maintained by your Internet service provider. Letter A. DNS Resolver. Letter B. Root name server. Letter C. DNS local cache. Letter D. TLD name server. The answer is C. DNS local cache. Number 4. This network keeps track of all the servers that maintain a directory of each domain, like .com, .net, .org, and so on. Letter A. DNS Resolver. Letter B. Root name server. Letter C. DNS local cache. Letter D. TLD name server. The answer is B. Root name server. Number 5. This server essentially takes control of the DNS query, temporarily becoming the DNS client. Letter A. DNS Resolver. Letter B. Root name server. Letter C. DNS local cache. Letter D. TLD name server. The answer is A. DNS Resolver. Number 6. This is the final step for the DNS query. Letter A. DNS Resolver. Letter B. Root name server. Letter C. DNS local cache. Letter D. Authoritative name server. The answer is D. Authoritative name server. Number 7. It maintains a directory of a specific domain. A. DNS Resolver. B. Root name server. C. TLD name server. D. Authoritative name server. The answer is C. TLD name server. Number 8. It is any temporary storage location for copies of files or data. Usually, the term is used in reference to Internet technologies. A. DNS Resolver. B. Cache. C. TLD name server. D. Authoritative name server. The answer is B. Cache. Number 9. It is another term for DNS server. A. Name server. B. Cache. C. TLD name server. D. Authoritative name server. The answer is A. Name server. 10. It is the process of storing copies of files in a cache or temporary storage location so that they can be accessed more quickly. A. Name server. B. Cache. C. TLD name server. D. Caching. The answer is D. Caching. This is the end of our lesson. Thank you and see you again on the next module.